this talk is Auditing PassRole. Dramatic pause. Finding the hidden trails of problematic privilege escalation permission. All right. For those in the room, please silence your cell phones and use the mic for questions. Let me know if you have questions. For remote attendees, we'll be looking at the questions on Slack and Twitter. And please welcome Noam Dahan. Ready to go.
Okay, yes, it's on. Hello, everyone. I am Noam. I'm from Tel Aviv. I'm a security researcher from Ermetic. We're a cloud security company that's identity first. Take a look at a lot of the cloud security angles from the identity first perspective, something that's been mentioned a lot during this day, and that's enough about me and the company. We're going to talk today about what PassRole is, privilege escalation with PassRole, the journey I went on to map it and try to find where it is, what it is, validation, both seeking it, finding it, and validating the API calls, results, and general advice on how to right-size it. Now, in 20 minutes, this is going to be a bit of a romp, but I'm going to try to speak slowly enough to be intelligible. Okay, so what is PassRole? And shout out to Rowan Adele for mapping this. And if you want to learn more about PassRole, the link at the bottom is to his great blog post about it. So PassRole is what happens when someone needs an AWS service to do something for them, to do something in their stead, to do something in their name. And in order to do that, you need to set up the service actor, whether that's an EC2 instance, the Lambda function, whatever it is, and you need to grant it the permission to assume that role. And in order for that to happen, there needs to be a check that's happening. So here we have depicted the classic example. There's a user, it assumes, and it creates an EC2 instance. The EC2 instance retrieves and assumes a role, creates temporary sessions for it, which it gives you, the user, through the IMDS engine, and then you can use your instance, access IMDS, do whatever it is you want to do, access your DynamoDB tables, or whatever it is you are doing. Now, the way that can be exploited maliciously is a malicious user who does not have admin privileges, can use this one, who does not have admin privileges and wants to escalate privileges can create a Lambda function or an EC2 instance or any other service actor, use a higher privilege role than the one they have. So for example, they could have EC2 full access permissions, which are not admin permissions, create an instance with administrator access, SSH into that instance, and from shell run whatever it is they like. So that's the classic PE. And in general, PassRole gets over-provisioned almost always. Almost in every account there is some over-provisioning of PassRole, which makes it Privesc magic. We have Ian here in the audience, a wonderful tweet which I think can resonate with everyone about Privesc with PassRole in red team engagements, internal engagements, and otherwise. PassRole start is super common, and the reason for that is not because it is cursed. The reason for that is that it's incredibly hard to provision. We'll get into exactly how and why that happens to be the case. So one might say, okay, just right-size it. We know stars are bad, you know stars are bad, just don't have PassRole star. And the reason it becomes problematic is that when you try to take this least privilege journey into right-sizing it according to actions or provisioning it correctly, you run into a bunch of problems. One, there's no CloudTrail logs, which is like sensible enough because it's not actually an API action, right? No one is reaching an end, is sending a message to an endpoint requesting PassRole to happen. It's part of a different request, but that does mean there's no CloudTrail log. Secondly, native tooling, unfortunately, in AWS does not support it. So if you use Access Advisor and you did do a PassRole thing, Access Advisor will tell you that AWS Identity and Access Management wasn't used. Thirdly, it is highly lacking in documentation. It's documented, I crawled the documentation, it's documented for 58 actions and 14 services it used to be. The final number, spoilers, we ended up with was in the 300s for the amount of actions, and also missing some of the most famous culprits, right? Like EC2 run instances isn't documented as PassRole, Lambda create function isn't documented as PassRole, so the documentation has very, very limited usability, if any. So we want to pin down PassRole in order to be able to find the breadcrumb trail, identify according to the different actions whether PassRole was used and what role exactly was passed, and then be able to right size it. So if I know that create function has in the request parameter function role ARN, and I see that event in CloudTrail, I can know that I need to keep the permission for PassRole for the specific role ARN that Lambda function used. So the idea is to find all the actions that actually require PassRole, map their role parameters from CloudTrail events, and use this like dual mapping, action mapping, resource mapping, in order to provision the actual permissions properly. A lot of P's in this slide and in this lecture, by the way, anyway, all along. So I wrote a little tool called BotoCrawl, not released yet, but possibly I will get around to it, which basically does what it says on the tin right here. It crawls Boto. Crawls Boto 3. If you are unfamiliar or need a refresher, the way Boto 3 works is that it stores in JSON schemas the entire AWS SDK. And so if you scan those schemas, you can statically, without slowing down for the actual API, find all the actions that have role-looking or role-smelling or role-adjacent parameters, right? We're not doing anything too magical here. We're just crawling actions and looking for something that says role, role name, role ARN, ARN, you know, just trying to pin that detector accurately enough to find things that look like PassRole. Naturally, this retrieves just a lot of read-only actions, like get role has a role ARN parameter. But we filtered the verbs, and then that does narrow it down into a couple of hundred actions. Next thing you do is approach it from the exact opposite direction. Query logs for potential PassRole events. So you look at what you go to wherever you go, Athena, Elasticsearch, Lake, Splunk, whatever you use, and look through request parameters for anything that references either as the key a role or role adjacent parameter, or as the value, just a role ARN that you're able to recognize by construction. Again, filter verbs, and you end up with this dual list that happily mostly overlaps. Like the overlap is very, very significant between these two lists. There's, I think, in single digits things that we were only able to trace through one of the ways. But that just gave us a list of automated guesswork, right? Because no one's guaranteeing that this action I've never seen in a service I've maybe heard of actually requires PassRole. Like, who knows whether ground station requires PassRole or not? Nobody, right? Unless there's some ground station users in the audience. In any case, I'd love a chat. But we need to actually go ahead and validate that by going out, doing the actions, and finding out whether they need PassRole. For this, we created a role with admin access, but also this custom policy, which is deny IAM PassRole star. So this role is allowed to do and is capable of doing everything in the world except passing, which is why, as a reluctant New York Knicks fan, I named it Mello, after future first ballot Hall of Famer who can absolutely do everything but absolutely cannot pass. So the role Mello has quite a similar problem. So we go around with Mello, trying to do things. We'll talk about how we're trying to do things in the next slide, but trying to do things, and then failing in ways that are interesting, and then, okay, once we fail, we say, okay, this actually required PassRole. We circle back to the event and find out in what way PassRole was needed. There's actually a much quicker trick you can do at home if you're trying to find whether something you're building requires a PassRole dependency, which is just give it a cross-account role. Every attempt to put in a parameter a cross-account role gives this detailed, specific error message of cross-account PassRole is not allowed. So let's say you made a mistake. You thought creating a service-linked role requires PassRole. Reasonable enough assumption to make, though it doesn't. You do it, and you don't get this message, or with create SLR, there is no parameter. Let's say you thought get role requires it, you do it, you get a different error which says you're not allowed to do this, but you don't get this error, and then you know that you're fine. And again, in order to validate and get events, you actually have to do the things. So we tried to fuzz it. I tried to fuzz it with AWS Trailblazer, which Will Bankston wrote. He's also here in the hallway con. If you meet him, there's a fork of Trailblazer, which Scott made, which does reverse regex for the parameters with Zegger, the Python library. But the problem you run into doing that is that Botto 3 schemas are at best a guesstimate. If this is what the parameter is allowed to be, this is what the Botto schema sometimes is. So they'll have something that needs to be an ARN, and the schema will be string. OK, it does need to be a string. Like, that's true enough, but it needs to be a specific enough string. So I have locally, and hopefully one day it will release a jerry-rigged fork of Scott's fork of Will's tool that, if it's ARN, tries to create an ARN. If it's some other recognizable thing, wraps around them. And then we were able to fuzz a couple of hundred APIs to actually get the CloudTrail event to do it. Another problem with doing it is that orders of failure are sometimes inconsistent. Like, some types of invalid parameters fail before access permissions, and some types of invalid parameters fail after access permission, and this just varies action to action depending on what kind of day people are having. So some of them you have to actually make them work. It's not enough to fuzz them with like bogus parameters or denied permissions. You have to actually make them work. So yeah, that's the second top level bullet here. Not manually doing the actions. Yes, manually doing dozens of actions. Fun times. And then after doing, also fails are nice, but oftentimes access denied doesn't have request parameters logged, so you can't use a fail to map the actual parameter that you need all the time, only some of the time. And then you run ahead, you locate role parameters in the events, and you can then go on your least privileged journey. You can then right-size the permissions, find out whether you need PassRole or not, and try to do your best. The results were 331 actions so far. They both are presented in, they both exist in a gist that I own, which has this inconvenient hash, but it's a gist on my GitHub, Noam Dahan. And they are upstream to IAM dataset, which Ian talked about last year, which is the dataset behind permissions.cloud. Permissions.cloud. So if you're using permissions.cloud, then you already have that dataset upstreamed to it. And then we had to stay on top of it for a year, which is like no magic solution, right? Just we could automate running the crawler and have an alert for that, but then the manual examination still needs to happen because no automated process that we created has a one-to-one fit with PassRole. So when AppRunner launched, just go ahead, try to do some PassRoles with AppRunner, you fail for the right reasons, and then you know you should add AppRunner to whatever it is you were using. Now some practical tips on how to right-size PassRole policies, because up until here this was like my whimsical journey through PassRole, but all you really need from it is the gist at the end. Good pun. Unintentional. Good job, GitHub. So how to right size. So the three things you want to do, and don't worry because they unfold into more detailed slides, is remove unused roles, provision carefully, and remove existing permissions. And this has to do with like the two ways to build cloud permissions, right? You can sculpt in clay, and you can sculpt in marble. Sculpting in clay means I'm trying to know exactly what I'm doing and pile on the correct permissions in a way that doesn't end up with too much excess material. Sculpting in marble is I take a big hunk of permission which makes the code work, and then I possibly try to hack away at that hunk of marble at a later date and possibly forget about it and just leave the hunk of marble in production. Kind of depends. But this is about giving you the tools to do it right, whether you are on the provisioning side trying to get the right permissions from day one, or trying to right size something that already works and now has to keep working but become less and less dangerous. So so the first thing to do is remove unused roles. And I know this is like unexciting, it's a very unexciting security risk, but it's important to remember that PassRole isn't really priv-esque to admin. It's priv-esc to whatever you left in the back of the fridge. It's priv-esc to the highest privilege unused role that somebody made and forgot about. And if the highest unused role in your environment is something that's still a decent use case for something good in production, then that can limit the effect radius, the negative effect radius for that type of damage. So that's the most boring, but maybe one of the most useful recommendations for actually having less terrible things happen to you in terms of priv-esc. The second thing is how to provision right. So first, we have the list, check the actions against the list, find out whether they actually need PassRole or not. Remember that creating service-linked roles does not require PassRole. A lot of excessive PassRoles come from that. People are saying, I'm establishing an SLR. I am ostensibly passing a role. You're not. AWS is passing themselves a role. You don't have the ball in this particular game. And use some use tooling. So both IAM Live, which I won't go into detail right now, but you run the code and it tells you the permissions, and access undenied, the tool I wrote about undenying access denied information, have the database embedded into them. And just avoid PassRole star at all costs, even if it makes the projects delay or things become harder, because the fact that it's an obfuscated way to make priv-esc easy in your environment doesn't mean that that's not exactly the checkbox that we are marking when we do this. And so you just have to be aware and have to avoid doing that whenever possible. It's kind of a, and as far as sculpting in Marble, removing existing permissions, so find PassRole star. You can use the AWS policy validations, some open source options like cloud splaining. There are a lot of tooling in this space, and just whenever you see PassRole star, hack away at it. And yeah, use the list to check against CloudTrail and then remove existing permissions. So you could absolutely build an Athena query or a Lake query or a Splunk query that says what types of actions is this principal using against a list of predetermined actions, and then figure out whether it needs PassRole or not. Lastly, there's a condition key. I am past the service. I like it. It's good. It does make it so that the principal can only do a PassRole to the service. However, understand that especially if you have not completed step 1 of removing unused roles, it doesn't really protect you from the primary risk, because this Lambda developer can escalate just to a different Lambda. It means they can't escalate into EC2, but they can escalate into Lambda. They can escalate into whatever it is that they do have. And with that, my time is out. These are my contact details. Feel free to ask me any questions if they crop up later, and any questions if you have them now. Thanks.
Was there any questions in the room for Noam? I'm worried people are getting tired. Or you're just that exhaustive with that resource list. So see if we have any questions in the Slack. Right.
And if you find some PassRole, upstream it. Comment on the gist. I update it as soon as I see it. And yeah.
Oh. You almost got away.
Thanks.
So like you said, the way to scope down PassRole is pretty difficult right now. If you could wave a magic wand and add any sort of capability or condition key to PassRole, and AWS would do it for you, what sort of things would you want to see that would make it less, you know?
I think the best magic solution here would be a two-pronged approach of logging documentation. So we need full documentation, preferably not in text, but embedded into the API that says, this is a dependent permission of IAM PassRole, and then people can, it can just be much easier, and we don't need to do like the dirty technical debt work. Second thing is, from the other side, find a way to log it. I know it's not an API action, so logging PassRole was used as maybe not the most natural way. You can perhaps log it as a parameter in a CloudTrail event in much the same way that we get what type of EC2 instance metadata was used as part of the CloudTrail event. And And the more consistently we can locate that, that would also be extremely helpful, because if it is within a dictionary inside the request parameters with a variable parameter name, that's not doing a lot for most customers.
Any other questions?
You mentioned using the Bodo SDKs, like the Bodo schema. Do any of the other SDKs just happen to have more specific schema, or like, you know, for further narrowing down which API calls need roles passed in?
So I think no. I think it's about the same. I am more comfortable in Python than I am in Go, so that's what I ended up going with. But I highly doubt there is a magic solution, and might be giving up coverage in one area to get better coverage. But I think they all operate in a similar way. If anyone knows differently, I'd love to learn.
Anyone else? All right. Thank you so much, Noam. I really appreciate it.